So when we multiplied the complex number times its conjugate, we got a real number. So this was the original problem. So the conjugate of 6 plus 2i, change the sign on the I only, is 6 minus 2i. So now we need to multiply top and bottom. So we're going to pass that 3 out. So we'd have 18 minus 6i. Now on the bottom, 6 times 6 is 36. 6 times negative 2i be minus 12i. 2i times 6 plus 12i. And then positive 2 times negative 2 minus 4, I times I squared. Now, the beautiful part is those i's cancel, which is what we want. What does I squared give you? It gives you a negative 1, and then times your negative 4 makes it plus 4. So what's in our denominator? So now, how do we write this as a complex number? What do we do with the 40? I think we practiced this somewhere, didn't we? Split it into 2 fractions. So we have 18 40ths minus 6 40ths I. Can you reduce that? What do we take out of this fraction? Got a 2. So it gives us 9 over 20, and then this guy? 3 over 20. So we have 9 20ths minus 3 20ths I. Okay? Let's try one more of those. Questions on any of that, where I went? Okay, so what if you have 5 over 6 minus 7i. 5 over 6 minus 7i. Okay, so what is our conjugate for 6 minus 7i? 6 plus 7i. We change the sign on the I. What you do to the bottom, you have to do the top. And so we'd have, we got to pass that out. So 30 plus 35i over 36 plus 42i minus 42i minus 49i squared. But 49i squared gives you what? Yeah, it's going to give us a plus 49. So we end up with 30 plus 35i over, this is negative 1. What's 36 and 49? 85. All right, and now let's split it. Or what could go into each of those 3 things? 5. But do you notice you have to take it from both of these things? Like if you leave it written like this, and you were reducing it, because sometimes you will see it like that. I have to take a 5 out of the 30. I have to take a 5 out of the 35. 5 out of 85 is what? 17. So you could see this problem written like this. Or 6 over 17 plus 7 over 17i. Just depends. If they tell you to write it in A plus BI form, it has to look like this. Real always first, imaginary last. All right. Let's take a look at another type. What if you had, this is example 3, 3 over 5 plus the square root of 7. Now, before, we just multiplied by the square root of 7 over the square root of 7, right? But when I multiply this by the square root of 7, what happens? If I take 5 plus the square root of 7 and I multiply it by the square root of 7, So did I get rid of the radical? No. So what would the conjugate of this be? 5 minus the square root of 7. Same idea, but now with radicals. So what would we have in our numerator then? 15. 3 square root of 7. 25. Minus 5 square roots of 7. Plus 5 square roots of 7. Minus the square root of 7 times 7 is 49. Those guys cancel. What's the square root of 49? What's 25 minus 7? 18. Three goes into all of them. So it could be written 5 minus the square root of 7 over 6. How else could it be written? 5 6 minus over 6 or 1 6. Either way. So multiplying by the conjugate. How do you know if you need it multiplied by the conjugate or not? What is there that tells me I need to do that? A radical or an I, but what else? Yeah, a plus or a minus. If there's a plus or minus here, we have to use the conjugate. No plus or minus, then it's easier. Questions on that? Take out your packet. Let's try a couple of those before we hit. So in your packet, in your unit, we are going to go to page 6. We're going to do, on page 6, numbers 75 through 85, odd. 75 through 85, odd.